Just a minute. Yes. So, dear student, today we shall be going to start very first third chapter, that is interconnected with the acid base. So some of the properties in terms of acid we have studied about the metals, and today we shall be going to start, okay, about this chapter. So if I'm talking that what are metals, what are metals? If I ask you that what are metals, what are metals? What are metals? So metals are those substances that are going to have either, don't write when I ask you to write, then you are going to write it only. Okay, Gianna and Harshit, please turn on your camera. Harshit and Gianna, turn on your camera. Are you there in the class?
So my camera is on.
But you are not visible to me. It is showing black.
I'm in India,
The
so
black
I
camera.
think
Okay, so what are metals? Metals are those substances that dissociate H plus ions in aqueous. Metals are those substances that, yeah, sorry, acid are those substances. First of all, I'm talking about the metals. Metals are those substances or those elements. We means metals. If I'm talking about these elements, we have broadly classified into three types. One is metals. The second one is metalloid, and the third one is non-metal. Non-metal. Okay, if I'm talking about the metals, what are metals? Metal are those elements that are going to have, means their atoms are going to have either one or two or three electrons in their outermost shell. In their outermost shell. In their outermost shell. Okay. And metals and non-metals are those substances that are going to have 4 or 5 or 6 or 7 electron in their outermost shell. Means either 5 or 4 or 6 or 7 electrons in their outermost shell, means outside shell, last shell. Outermost means the last shell. Okay. So we call them metals. Non-metals. What are non-metals? Non-metals are those substances that are going to have okay, that are going to have either one or two or three electron in their outermost shells. Or if I'm talking about the metals are those substances that are going to have either one, two, or three electron in their outermost shells, while non-metals are going to have 4 or 5 or 6 or 7 electrons in their outermost shell or the last shell. Okay. And if I'm talking about the
Sir, you're muted.
Sir,
Sir,
we can't hear you. You're muted.
why are you not telling me from the last 5 minutes? I have been continuously teaching you.
No, not from the 5 minutes, only like 1 minute.
Okay, so what I'm saying here is that metal are those substances, okay, that are either going to have one, two, or three electron in their outermost shell. Means in the last shell, they are either going to have either one or two or three electron in their outermost shell, while the element which is having, or the atom with 4 or 5 or 6 or 7 electron in their outermost shell, or the last shell is called, we'll simply say that they are called non-metals. Okay. Understood? Yes or no? Gianna,
Yes, sir.
camera is not working. Okay. Moving to the next part here is that, like, for example, if I'm talking like next one, if I'm talking about the metals generally lose their electrons in order to attain stability. Metals generally lose electrons. Why? Because For example, if any element having 281 electronic configuration, okay, 281 electronic configuration. So you will check here that 281. So last shell is it is metal, and in order to attain stability to the nearest noble gas, what are the electronic configuration of the noble gas? That they have, okay, they are helium with 2 electrons. Helium is the first one. Helium, then neon, helium, then neon, 2,8, then argon, 2,8,8. So some element loses the electron in order to attain the stable electronic configuration to the nearest noble gas. For example, here this is sodium Na, which is going to have 281 electronic configuration. So it will lose one of its electron to have the electronic configuration to the nearest noble gas, that is neon. Like similarly, magnesium 282, aluminium 283. They are all metals. They will lose the electron in order to attain stability. But what about the oxygen? 2,6 electronic configuration of oxygen. So it will not lose 6. It will gain 2. It will gain 2. So when an element gains electron, it is going to have negative charge. When it loses electron, it is going to have positive charge. So coming back to the previous part here is that metals are those substances which is going to have either 1 or 2 or 3 electrons in their outermost shell, except we have something here, except hydrogen, which is going to have 1 electron in its outermost shell, and another one is after hydrogen, we have the next one is helium. These are the exceptions, okay? That is going to have 2 electrons in its outermost shell. This is noble gas, and this is neither metal nor metal. Similarly, non-metals, when gain electron, they become electronegative element, okay? Electronegative. And then we'll simply say that they have tendency to gain electron because they are going to have 4, 5, or 6, or 7 electron in their outermost shell, while the 1 or 2 or 3 carriers will lose electrons. And when they lose, they become electropositive. When an element gain electron, it becomes negative. Like for example, chlorine has electronic configuration 287. When it receives 1 electron, so it will acquire 1 negative charge. And now its electronic configuration will become 288. It is the nearest noble gas argon electronic configuration. Nearest noble gas argon electronic configuration. Similarly, sulfur 286. So it will gain 2 electrons, in order to attain stable electronic configuration of 288. Understood? Yes or no? Yes or no?
Yes, sir.
Okay. So start writing from here. First memorize it, and then first I'm just going to read it for you. You have to memorize it first, and then you have to start writing it. Okay. So these are the elements that have generally 1 or 2 or 3 electrons in their outermost shell, except hydrogen and helium. They lose electrons and form electropositive ion. They have low ionization energy. What is ionization energy? Tendency to lose electron. So metal generally take less energy because they want to be stable, so they will lose the electron easily. While metallites show the property of both metals and non-metals, while in non-metal generally have 4 to 7 electron in their outermost shell, either 4, 5, or 6, or 7 electron. They generally gain electrons and form electronegative ions. They have low electron gain enthalpy, means they can easily gain electrons, so they have low electron gain enthalpy. And what is ionization energy? We're going to discuss. So please note it down fast. First revise it. First memorize it. Don't write it. First memorize it. Done?
No, sir.
First memorize it. Then you have to write it down.
So what's the last word in metals after low
They
ionization?
have low ionization enthalpy. Enthalpy means energy. Done? Harshit, done?
No, sir.
Memorized? Done? Start writing. If you noted? Done?
No,
Noted fast. Done, yes or no? Harshit, Aisha, done?
Yes, sir.
You also? Maha and Gianna, done?
yes, sir.
Okay. Check whether you missed some point or not. Check whether something you missed. Done? Checked? Okay, now start doing this question in your notebook. Write down question number 30 in your notebook and tell me which option is going to be correct. Question number 30. Done? What should be the answer for this question number 30? Aisha, Gianna, and Harshit, you, Maha. What should be the answer for the question number 30? Is I'm audible
Sir
to you?
D. Sir D.
Yes, you, Maha. What could be the correct answer?
D.
Aisha, you,
D.
and you, Gianna. Gianna, are you there?
Yes, sir.
What could be the correct answer for this question number D?
Sir, D, Y is a non-metal.
Okay, yeah. Y is non-metal because it is going to have 4 to 7 electron in the outer motion last step. And X is Z is metal because it is going to have 2 electron in its outer motion. Okay. So note it down fast. You done this question? Yes or no?
Yes. Sir.
Okay, let's move towards the physical properties of matters. What is ionization energy? Write down the definition of ionization energy first. That is the amount of energy that is being required to remove an electron from an isolated gaseous atom. Isolated gaseous atom means, for example, you have chlorine. For example, you have sodium. So you have to convert sodium solid into sodium gas. Whatever the energy required here, it is not considered to be as ionization energy. It is the normal enthalpy energy. But when it is in gaseous state, then you have to convert it by removing one electron from its outer motion, and it will be known as ionization energy. Ionization energy. So only one electron you need to remove from the outermost shell of an atom. That is considered to be as its ionization energy. And since the metals wants to lose electron fast, metals wants to lose because metals have 1 or 2 or 3 electron in the outermost shell, so they will easily lose their electron. So when they lose their electron, they'll simply say that metals have low ionization energy. Okay. So memorize this definition, then write it. Memorize this definition, please. You done? You noted? Memorized? Yes or no?
Sir, that
Yes.
is Na plus
It is the
Ve.
outermost, it is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. Isolated gaseous atom. Like for
In
example, sodium is solid. So here this energy is first you will convert it into gas. This energy is known as whatever this energy is required. So let it be. But ionization energy is that when you are going to remove an electron from its gaseous form and only one electron you are going to remove it. Okay, it is always positive, means it is endothermic process. When removing an electron is always endothermic process, means you need to give the energy. So in case of metals, if you want to remove the electron, they can easily lose electrons with very less amount of energy required. Okay, understood? Yes or no? Now memorized this one?
Yes, sir.
Okay. So tell me this one, that what is ionization energy? Tell me, what is ionization energy? You memorized? What is ionization energy? Tell me, Arshit. You memorized, na? Tell me what is an ionization energy? You noted this one?
Yes. Yes, sir.
Tell me. Then
Sir, it is the amount of energy required to remove an electron from its outermost shell. That is uh, iso isolated gaseous atom.
yes, isolated gaseous atom. Yes, you are Aisha. What should be the answer for the ionization energy? What is ionization energy?
It is the amount of energy required to remove an electron from outermost shell of an isolated gaseous atom.
Okay. Yes, you. Maha.
So it is the amount of energy required to remove an electron from its outermost shell of an gaseous atom, isolated gaseous atom.
Isolated gaseous atom. Very good. And it is positive always or negative?
It is always positive.
Means
Uh,
indicating that it is an endothermic process or exothermic process?
Endothermic process.
Yes, it is an endothermic process. Now, these are the physical properties of metals. That metals generally have very high densities. Like the iridium is the one which is going to have the highest density of 22.5 gram per centimeter cube. And the lithium is the lowest, which is going to have 0.5 gram per centimeter cube. Means if you make a volume, if you make a cube, Rubik's cube, like small cube, having dimensions of length, breadth, and height, solid cube. Okay, if you are going to have solid cube of 1 centimeter length, 1 centimeter breadth, and 1 centimeter height, like this, like a bigger Ludo ball, Ludo. Okay, Ludo. What we called it? Dana in
Dice.
dice. Yes, dice. So like a Ludo dice. Okay. So here we'll simply say that they are going to have highest density. If same dice, if we are just going to make it from iridium, it will weight at 22.5 gram. If we make that same die with lithium, it is going to have only 0.5 gram. So lithium is very lowest density metal. Second one is that high melting and boiling points. If I'm talking about the high melting and boiling points, so they have very high melting and boiling points. Metals generally have very high melting and boiling point, except the gallium and cesium, which has the lowest melting point near the room temperature. Means they are going to, means they can easily, if you kept it the gallium and cesium only in hand, it will melt because our body temperature is 37, and its temperature, or we can say that the temperature of melting point of gallium and cesium is 25 degrees Celsius. You understood? Yes or no? Done.
So can you
Next,
explain it again?
next, if I'm talking about the solid, so
No, sir.
yeah,
Can you explain the high melting and boiling point again?
yeah, melting, because they have metals are very, because they, in metals the atoms are easily tightly packed together, and they have a special metallic force. or electrovalent force we called it. So because of that, we can simply say that because of the high force of attraction between the particles of metals, we'll simply say that they are going to have very high melting point because we need to overcome the force of attraction. You understood? But gallium and cesium are the two metals that are exceptions that has very low melting and boiling points. Okay. Done. Then if I'm talking about this one, uh, high they have like generally they are solid, but except mercury, which is a liquid at room temperature, they are shiny, lustrous. Example, silver is the most shiny metal. Malleable means they can be bitten into thin sheet, and ductile means they can be drawn into thin wire. Okay, they can be drawn into thin wire. So we can simply say that non-metals are generally shiny. They have very high melting and boiling point. They are generally solid except the mercury. They generally have high melting and boiling point except the like tungsten is going to have the highest melting and boiling point. Similarly, if I'm talking, there are some elements that boils easily at room temperature. Okay, so accordingly we have to write it. Okay, so write first, memorize it, and then let me know. Memorize it fast. You noted? Sorry, you memorized. Memorize it, which has the highest melting and boiling point. Okay, Arshit, I'm going to ask you, and Gianna, you have just turned off your camera. So I'm going to ask you, each and everyone, please memorize it in deeply. Tungsten has the highest melting points, and gallium and cesium has the lowest. If I'm talking about means they have low, I'm not saying lowest because mercury is liquid, which is always liquid. Okay. So mercury freezes at very negative temperature. So we can say that the lowest melting point is in solid is of mercury because it is already, but gallium and cesium are the metal that they can easily melt. Harshit, you doing?
Yes,
Memorizing?
sir. Yes,
Memorize
sir.
it fast. They are malleable and ductile. They can be easily drawn into thin sheet. Okay. Done. They are generally hard, but alkali metals are so soft that they can be easily cut with the help of knife. Like sodium and potassium are soft metal. They can be easily cut with the help of knife. Yes, you, Gianna, Aisha, and you memorized. Will you able to write it in your own words? Should I remove it? Harshit, you memorized?
Yes, sir. Now,
Gianna, you memorized?
Yes, sir.
And you, Aisha?
Yes, sir.
And you also, Maha? Memorized?
Yes, sir.
Okay, try to write it in your own words. Try to write it down. Harshit, what are you doing? Why are you not writing?
Sir, I'm writing that I was
While
recalling.
looking upward? Done? Yes or no?
No, sir.
Noted fast. Yes, noted. Gianna, you have noted this one, yes or no?
Sir, almost.
Harshit, tell me which is the highest density metal? Which metal has highest
Sir,
density?
it is iridium. Has the highest density is 22.5 gram centimeter cube.
And that of lithium?
0.5 gram.
0.5 gram.
And centimeter cube.
You tell me which is the most shiny metal? Most shiny metal.
Me, sir.
Yeah,
Silver.
very good. Okay, tell me that which is which metal has boiling point near room temperature. So melting point near room temperature.
Mercury, sir.
Mercury. Okay. Okay. Along with gallium and cesium. Gallium and cesium also have melting point near room temperature. Okay.
Okay.
Understood? Yes or no?
Yes.
Aisha, you understood? Yes or no?
Yes, sir.
Okay, tell me which metal? Yes, you, Aisha, tell me which metal is the which metal is going to have the highest melting point?
Tungsten.
Hmm?
Tungsten.
Tungsten. And the formula of tungsten is? Formula of tungsten is? Yes, you, Gianna. What is the formula for tungsten? Gianna, is there in the class?
Yes, sir.
What is the formula for tungsten? Symbol. Symbol for tungsten.
Sir, W.
And W. Okay. Tell me that which metal is the most ductile metal?
Sorry, sir.
Which metal is most ductile? Which metal is most ductile? Ductile and malleable. Gold is the most ductile and malleable metal. Okay.
Yes, sir.
Even gold is so ductile that 1 gram gold is enough to drawn into a thin wire of 2 kilometer length. Okay.
Yes, sir. Yes, sir.
Next. Okay. So check whether if you have uh, committed or missed something or not. Okay. In the property, then we shall be going to proceed the question towards this. Check whether if you miss something. Yeah. Check. Done. Did you miss something? Check it. You done?
Yes, sir.
Okay. So let's move towards the next properties from this one. Okay. There are some properties for non-metal also. Like Means metals, if I'm saying that metals are good conductor of electricity, then non-metals are bad conductor of electricity. So what does metal do? The non-metal do it opposite. But there are some exception in non-metals also. Like all non-metals are bad conductor of electricity except the graphite, which is a allotrope of carbon. What is allotrope of carbon? We're going to study in the carbon and its compound chapter. But here what I'm saying is that graphite is that element which is going to which can conduct electricity, which is a good conductor of electricity. Okay, you understood? And bromine, like the mercury, all metals are solid except mercury, which is liquid. And all non-metals are either gas or solid. But bromine is the only non-metal that is liquid at room temperature. Okay, you understood? Except and here all metals are dull. Sorry, non-metals are dull because if metals are shiny, lustrous, so non-metals are dull. Except the iodine, which is a non-metal, which is shiny. Diamond is an allotrope of carbon, which is also shiny. Brittle means they can be easily broken if you hammer it. So they can be easily broken. But since exception is generally being asked in the examination, so that is more important for you that you must learn the exception. Like for example, non-metal can be easily broken when you hammer it. Like for example, if you hammer the metals, they can be drawn into thin sheet. Okay, they can change their shape, they can distort their shape, they can be distortion in their shape. But here if I'm talking is that for the non-metals, if you hammer it, they will, like for example, if you hammer the wood will break, it will not expand like the metal does. Okay, so non-metal generally breaks, they are brittle, they can be easily broken, but except the diamond is very hard, naturally occurring substance, which is very hard and dense. Okay, so diamond is a non-metal because it is actually carbon. Diamond is carbon. Okay, so but it's due to its special rearrangements of atoms or arrangements of atoms in the tetrahedral discipline that we're going to study in the carbon's compound chapter. So that's why non-metals are generally brittle, they can be easily broken, but except except diamond, which is very hard, naturally occurring substance. Okay, understood? Yes or no?
Yes, sir.
Understood?
Yes,
So
sir.
please memorize this fast.
Sir,
Yeah,
sir, what have you written after diamond?
what I've written
What you have
after
diamond?
diamond is allotrope. Allotrope, ALLOTROP. It is allotrope. ALLOTROP. It is allotrope. It is allotrope.
So what does allotrope mean?
Allotrope is the actually different forms of an element that exist in nature due to different arrangements between their atoms, particles arrangement. Like for example, in carbon, in graphite, carbons are arranged in a hexagonal structure like this way. That we're going to study in the carbonates compound chapter. Don't worry about it. So they are arranged like this way in a hexagonal structure. Okay, but in diamond they are arranged in a tetrahedral structure. So this will study there also that why diamond is good conductor of bad conductor of electric current, while we can simply say that graphite is good conductor. Why graphite is good conductor? They both are carbon, but due to different arrangements, here it is arranged in a tetrahedral structure like a tripod. Here like this way, they are arranged like this in this structure. Okay, but in graphite they are arranged in hexagonal structure. So arrangements of same atoms, same atoms, but in different form result in the different physical properties of an element. Like graphite is good conductor, it is a physical property. And diamond is very hard substantive, its physical property. But if you burn both diamond and graphite, they will give you carbon dioxide and heat. So if you are heating, it does not mean that if you are heating graphite and something other else, it will give you bad quality of carbon dioxide. And if you heat diamond, that will give you very good quality of carbon dioxide. No. They both are carbon. Due to arrangements, their chemical properties does not change. Okay, you understood? Yes or no?
Yes.
So is it due to the structures that diamond is hard while graphite is
Yeah,
easily?
yeah. It is the arrangements of atoms. That is making it different. Different. Okay. Memorize it fast. Basic. You done? Memorized? Yes, you, Gianna, you done? You memorize this one?
Yes, sir.
Which metals, which non-metal is most shiny non-metal? Which non-metal is most shiny non-metal? Shiny. Yes, Harshit?
Sir, it is iodine.
Iodine. Okay. So, okay, start writing this one, please, in your own words. Done. Note it fast.
Done, sir.
Noted. Okay. Check whether if you missed something. Check whether if you missed something. Done. Noted fast. Harshit, check whether if you missed something.
Yes, sir. I'm doing.
Good. Okay. You're still having something. My writing.
Done, sir.
Yes, you, Gianna. You done? Noted.
Yes, sir.
And you, Aisha?
Yes, sir.
Okay. Now let's move further towards the question. Question number 1. What should be the answer for this question?
Sir,
Option C.
C.
Which of the following property is generally not shown by metal? Not shown by metal. See, dullness. They don't show dullness. Next, the ability of metal to be drawn into thin wire is known as?
Reliability.
Yeah, it is ductility. This one?
Sir, D.
Aluminum is used for cooking material utensil. Which of the following property of aluminum are responsible for the same? Good thermal conductivity, because we need utensils which can easily conduct heat. And second is
High
duct high melting points. 1 and 4. Okay, high melting points. Okay, tell me question number 19.
D, iodine.
Iodine. Okay, iodine. Tell me question number 25.
Sir, B option.
Yes, sodium and potassium are so soft metal that they can be easily cut with the help of knife. Okay,